Hello, welcome to another video. What you see here is a contactor. A contactor is an electric device that uses to switch on and switch off electric circuits. So the work of a contactor is the same work that a switch does or a circuit breaker, but the only difference is that a contactor does it automatically without man's intervention or involvement. So that's the only difference between a contactor and a switch or a circuit breaker. So inside this contactor there are some electromagnetic relays. These relays are the ones which, when they get energized, they make contacts between point A and point B. So this contactor that I'm holding, these parts that you see which are marked L1, L2, L3 and normally open, these are points of a contactor or contacts that that's where electricity or current is transferred from point A to point B, or that is where contacts are being made automatically. So in this video we are going to see how this contactor works automatically and how what's the difference with other switching devices like the switch and the circuit breaker. We'll see. So before we talk about that, let me explain about the points of a contactor. These points which are on flat here. There is the first point of a contactor, which is A1, this one. So the A1 is the positive part of a contactor. This is where you put your live cable if you are to energize the contactor. So you put your live cable to the A1, this point here. This is where you put your live cable. Then the other point is the A2. The A2 is the negative part of a contactor. So when you connect your A1 and A2, live and neutral, this contactor gets energized, or the electromagnetic relays which are inside, they get excited, making these points here, the L1, to connect with the T1 which is down here. So these points, when they get excited or when they get energized, if there is current at L1, current will also be there at L2, meaning the normally open will close, then the normally closed will open. So power goes from point A to point B when this contactor is energized. It's like when it gets energized, it's like someone switches on the switch. It happens automatically, like the way we switch on the switch or the circuit breaker. This contactor, once it gets energized, it does that automatically. So that's the difference between a contactor and a switch. So the normally open is this means that when this contactor is not energized like the way it is here, we have not connected anything to this contactor. It is not energized, it is at rest. So meaning normally open, the point A to point B, the contacts, these two contacts, there is no power here because it is open. But for the normally closed, means that when the contactor is at rest, there is power from point A to point B if it's normally closed. But for normally open, it means when it is at rest, there is no power from point A to point B. But when it gets energized, the normally open will close, meaning there will be power from point A going down to point B at 14. So this is all we have to know about a contactor. Now we are going to do a small assessment to see how this contactor works, how we can connect the electric devices or appliances to this contactor and to make it work automatically. So I have two lights here. We'll see how we can connect these two lights. This one that I'm holding is an auxiliary relay. We use this auxiliary relay to increase the number of contacts. As you can see, it has a combination of normally open and normally closed contact. For that contactor, it only has a normally open, but if we put an auxiliary, we'll increase the number of contacts, meaning we'll have more contacts. We'll have more normally open and normally closed contact, so as to increase the chances of making an automatic switch. So we are going to see how this auxiliary and the contactor works to perform an automatic operation, or to switch on an automatic appliance automatically, switching on or off. The work of this contactor and auxiliary is either to switch on or to switch off. It can be a generator, it can be a motor, a machine. We can connect it so as to switch on or off at a certain period when it gets energized. That is the work of it. So I'm going to connect two lights on normally open and normally closed, meaning those lights will not work at the same time. When the contactor gets energized, one light should go on while the other one goes off. We are going to see how we can do that. So let me connect the contactor A1 and A2 respectively. A1 from the source, that's the live cable, and now I'll be connecting A2, which is the negative part of a contactor, from the neutral or the ground. So I'm putting the neutral at A2. By doing so, I'm done as far as energizing my contactor. The way it is here, it will be energized. Once I switch on the source, this contactor gets energized, and the electromagnetic relays which are inside, they get excited or they get energized. Okay, so this is what happens. As you can see, this contactor is energized. The points from, so this is normally this is A1 and A2. This is where the power source, this is where the power comes from A1 and A2, negative and positive respectively.
So now let's see now how we are going to, how these contacts work after the energized.
So I'm going to use these two lights to show you how a contactor works. You can still energize the contactor without putting an overload and without putting a auxiliary relay. You can still, you see, you can still energize it as it is, but we put this auxiliary relay just to increase the number of contacts. As I explained, an auxiliary relay is a combination of normally open and normally closed. A contactor only has normally open, but for us to have a normally closed contact, we'll have to put an auxiliary relay so as to increase the chances of making an automatic switch for an appliance that we want to switch on automatically. So I'll be connecting the lights. This power that is energizing the contactor is not on the points which are there, the normally open points. So I have to get the power from A1 and put it at the inlet of the contact that I want to use. So I'll put it at the normally open contact. We know that normally open, when the contactor is at rest, the normally open has no power at the outlet. So as it is now, power is only coming from A1 to the inlet of normally open. So I'll connect my light from this normally open at the outlet of the normally open contact. So my live cable, I'll start with the ground. Ground will go direct to the neutral bar respectively. So I'll connect the ground here from the light. Then the live cable will go to the outlet of the normally open down here. Remember, the normally open has no power when the contactor is at rest, so we don't expect any power coming from the normally open contact. The light remains off as long as the contactor is not energized. So what will happen here, when I switch on the source, the light goes on because power now is coming from the normally open outlet, then it goes to the inlet, then it comes back to the outlet to energize, to switch on the light. So this is how a normally open contact works. When it gets energized, it will close. Then when it is not energized, it is always normally open. No power goes from the outlet. Now, this is where now an auxiliary comes in. What if we want the light to go off when the contactor is energized? What happens? This is where this is the time when we add an auxiliary relay. Like I mentioned, an auxiliary relay has a combination of normally open and normally closed contacts. So for us to have the light going off when the contactor is energized, we have to put the light at normally closed, so that whenever it is energized, it opens. Remember, there is no power coming from the auxiliary, so we have to take power from either A1 or where it is, then to put it to the inlet of the auxiliary normally closed. We put our ground to the neutral bar for light number 2. Then we put our line cable from the outlet of the normally closed contact. So here the light cannot go on unless we get the power from the source. The inlet power should be from the source. So I'm going to get power from the source and put it at a normally closed contact. So I'm getting power from the source, then I'll put it at a normally closed contact. So the inlet of the normally closed contact, then we put it at the source. This one is direct, it will not go to the circuit breaker. So we expect this light to be on even though the contactor is not energized. That's the normal way of doing it. This light needs to be, the second light needs to be on even if the energizer is not, the contactor is not energized. So this one happens if the relay is not, so the auxiliary relay is not okay. But once the auxiliary relay is fine, okay, it has responded. So this light is, this is what happens. When the contactor is energized, the light goes on. When it's de-energized, it goes off while the other one goes on. So these two lights, they cannot work at the same time because one is at normally open, the other one is at normally closed. So this circuit works when you are making a generator changeover switch. When the genset is running, the main grid is not running. When the main grid is running, the genset is not running, is off. They don't work at the same time, or they interchanges. That's the principle of a contactor. Okay, thank you for watching. This has been Sammy's Network. This is all we had for you for today. In the next videos, I'll show you how to connect the traffic light circuit, the robot circuit, how those traffic lights work using the principle of these contactors and the timer. We're going to do that circuit, that assessment. We'll see how to do it. Thank you for watching. This is Sammy's Network. If you haven't subscribed to this YouTube channel, make sure you hit that subscribe button. And if you find this content to be helpful to you, please give us a like. And also you can comment your thoughts on the comment section to tell us what you think about this principle of a contactor and the future videos that you want us to do for you as far as the engineering concerned. Thank you very much. Have a blessed day.